Okay, so geometry. So we'll write down a whole bunch of definitions, just like quadratics. I don't know if you remember, we wrote down a lot of, so that's what we're going to do. Okay, definitions. So we've got types of angles. Right, we've got acute, which is less than 90. Obtuse, greater than 90. Got straight. Okay, so straight angle would be if you consider a straight line, right? If you measure it from, if you pick any point on this line and you measure the angle, it's 180 degrees, okay? And obtuse is just like this, right? It's greater than 90, 90 being your vertical, and then obviously the acute, you'd think of anything that's less than 90. So the 90 is your reference. Pearl is here, okay. Okay, thank you. Okay, so we've got acute, obtuse, straight. Nothing new there, I'm sure. Maybe one thing that I want to mention here, right, is that, and it kind of ties all of these together, is that if you have a straight line, right, and you cut it, it doesn't matter how you cut it, but if you cut this 180-degree angle, right, you would have one acute and the other side being obtuse, right? But the fact is that they still always add up to 180. Okay. And you've got supplementary angles. Angles whose sum is 90. I don't know if you've ever seen anybody do that, but you can do that, right? Just saying the same thing, right? If you can develop something like that for note taking in university, if you go to college, university, anything, you're sometimes the professors they're not trained in the art of teaching. They just know a lot about the content. I'm serious, right? They don't go into how to teach. They just go in, they just know their stuff. So they'll be brutal sometimes with note taking. They'll just throw something on there and take it off within a minute, right? So you have to be really good at taking down as much as possible. Next, definitions. Parallel lines will never intersect because their slopes are equal. You remember slope, rise over run? And I don't know if you remember, but a system, like if you had two lines that had the same slope, that system would not have a solution, right? Because they would never meet. And so the same thing here, parallel lines will never meet because of their equal slopes. In fact, in IPR, you would check whether two lines were perpendicular or parallel, right? Just by looking at the slopes. We say that AB is parallel to CD, comma, if segment AB is parallel to CD. Okay, and I'll give you a diagram that goes with it. Okay, so just draw two lines like that, and so this would be segment AB. So on this line that keeps going indefinitely on either end, you're delimiting it by 2 points, right? You're referring to this segment here and this segment here, which is CD. Right? We say that AB is parallel to CD if AB is parallel to CD. And notice that we use arrowheads in between the lines to indicate that they're parallel. So if you ever see this, okay, that means that they're parallel. So indicate that lines are. So it'll either be mentioned in the word problem, or you will have to look for these markings that tell you that these lines are parallel. So you could also have a scenario where you have two lines going this way. Oh, sorry. So you could have two lines going this direction and then two lines going in this direction. And this can vary greatly, okay? I will try to give you as many examples as possible. But let's say the textbooks and whatnot, they will have a marking like this. They will have an arrowhead in the middle like this. And this tells you that these two lines are parallel. And if they're also telling you that these lines are parallel, they would have to use two arrowheads like this. Okay? So you would essentially say that lines are parallel, right? And you could also say that lines are parallel. But don't always assume that they're parallel. Look for markings, right? Some students say, oh, they kind of look parallel, so I'm just going to go ahead and say that they're parallel. That's not true. Okay, you have to look for the markings for that to be accurate. The one thing I need to do, I'm reading the chat now. but not while I'm teaching necessarily. I'm just going to have it on people, and when somebody types something in, then I do get a notification. Okay. All right. You doing okay? Okay. Transversal lines. I'm just going to go transversal. A transversal is a line that cuts two or more at distinct points. So examples, right? If you have two lines going like this, and I'm going to use a different color, right? This would be your transversal there. Okay, it's good because this is a line that cuts through one or more like that. You could have just a bunch of lines going every which way, and you could have, right, this is a transversal that cuts through a bunch of lines like that. And so we're going to look at, right, the transversal. You will want to follow it sometimes and look at the angles that are resulting from it. Okay, that way you will notice certain patterns, right? And so the next one here, you have to try to make a decent diagram. Okay. So what I'm about to give you here, you should definitely have on your study sheet. You can have a very short version, small diagram when you transfer it. I'm going to use my ruler on this one. And I'm going to take up pretty much this whole space here just to make sure it's nice and easy to see, okay? So just pick an angle, okay? And make two lines like this. And then we're going to have one line cutting through it like this. We're going to put points here, between here and here. I'll put a dot there, dot on this end. So basically every line has a beginning and an end, okay? And you go A here, B there, C, D, and then E, F, like that. And we're going to hone in on the angles that are created by this is technically the transversal in this case, the angles that are created here and the angles that are created here. Okay, so we're going to call this, we're going to start at the top just to make it easier. We're going to start here with 1, and we're going to go clockwise around and call this angle 1, 2, 3, 4. And then we're going to go to the bottom intersection here and call this 5, 6, 7, 8. Okay, so you go around 1, 2, 3, 4, 5, 6, 7, 8. If this is your transversal and these two lines are like that, right? They could be parallel, they could not be, we don't know at this moment. Anything inside of it, I want you to think of a sandwich. This is your bread, right? This would be considered interior. Anything between these lines would be considered interior. Inside, right? Anything outside would be considered exterior. So I'm gonna kind of in trouble here, but I'm talking about exterior up here, exterior here, and anything here is interior. So this will get a bit more complex later on, but for now we're just going to keep it simple, okay? Now, we're going to actually label our triangles here. So interior angles, angles within two lines cut by transversal. Angles within two lines cut by transversal. So that would be angle 2 and 3, as well as angle 5 and 8. These 4 would all be considered interior because it's right there inside the two lines that are being cut by that transversal. So then we have exterior, and I'm just going to go cut by T. Okay, you're going to know what that means. So in that case, that would be angles 1 and 4, angles 6 and 7. Okay, so 1, 4, 6, 7, they're exterior angles. So we call them exterior. So if I ask you, you have to know that. Okay. Corresponding. This is going to be new. Okay. Watch the definition. It's going to be a little confusing, but when you practice it, you're going to be all right, right? An interior angle and a non-adjacent exterior angle on the same side of the transversal. An interior angle and a non-adjacent exterior angle on the same side of the transversal. And then we're going to refer to our diagram up there to get this right. So you've got interior, exterior, corresponding. Okay. Which ones would those be in this case? And I'm going to let you copy this first before I talk about it. Okay, so this is how you find corresponding angles. So this would be a pair. They're always in pairs. Okay. So we'll go up and say pick an interior angle, any one of the interior angles, for instance. So let's say you pick 2. So it says one interior and one exterior angle that is non-adjacent. What does non-adjacent mean? Anybody? They're not next to each other, right? If it's non-adjacent. So it cannot be any of these guys here, because adjacent basically means also touching or next to. So it has to be one interior and one exterior that is non-adjacent on the same side of the transversal. So the only, if all you can pick from is this side, it has to be on the same side of the transversal, and it cannot be touching, then this one would have to go with 6. Angle 2 corresponds with 6, because if you think about it, this is interior, exterior, they're not touching, and they're on the same side of the transversal. So 2 and 6 would be one pair. So let's go down here and say 2 and angle 6. That's one set of corresponding angles. So write that down, 2 and 6. Let's go back up. So I'm going to use my pen here. If 2 and 6 are corresponding, let's just go over to the side. 3 and 7 are also. So 2 and 6, 3 and 7. So let's write that down. Angles. It doesn't matter. That doesn't matter as long as that pair is correct. Okay? These two are called corresponding. These two are called corresponding. So it doesn't matter which one you give first, as long as you know that they are a pair. Okay? All right, let's go back up. So if 2 and 6, and then 3 and 7, now let's jump up. 4 and 8 are also. Okay, so I kind of go around. I go 2 and 6, 3 and 7. Let's go up 4 and 8, as well as 1 and 5. So 4, 8, 1, 5. Okay. 4 and 8. Angle 1 and 5. So you've got four pairs of corresponding angles in this particular case. Okay. I'm going to just do this here. Alternate exterior and here we're just going to come up with the pairs. These are also pairs. So we've got our corresponding, like interior, exterior, they're just single angles. So you just list them, right? These are all on the inside, these are all on the outside. Corresponding is you would have pairs. Alternate exterior, you also have pairs. So let's go back up and identify them. Alternate means on the opposite side of the transversal. So 1 and 7 would be considered alternate exterior, as well as 4 and 6. So they're both, the name says it all, they're both on the outside and they're on alternate. That means that across the transversal, you're actually crossing the transversal to get the other one. So 4 and 6, 1 and 7, or if you want to go 7 and 1, 6 and 4, it doesn't matter. But these are the two, okay? So let's write down angle 4 and 6 and 1 and 7. So the name says it out, right? Like exterior, alternate exterior. So they're all on the outside of those two lines that are crossed by the transversal. And I know it's going to be a little tight here, but I'm going to do that anyways. Alternate interior. Alternate interior work the same way as the alternate exterior, except for this is telling you that you have to pick from the inside between the two lines. Okay, so in this case it would be, if this is an interior, then alternate interior to it would be 5. So 3 and 5, 2 and 8. Okay. And these are also pairs. So a question would be, which angle, or state all the interior angle pairs, or just the interior angles in this diagram. You'd have to just grab the right ones and identify, okay, these two are alternate interior, these two are alternate interior. I could ask you, state all the alternate exterior angles in this diagram. You have to go grab the right ones and just know what does that alternate mean. Oh, it's a cross and they're both on the outside. Okay, so grab the right one. You have to know corresponding, right? How do you do that? Well, there are lots to choose from. I might just ask you for one or two, right? Or all, it depends. So you got to know to be able to identify them. Okay, let's keep going. Are we good writing this down? Yeah. Okay. So we're gonna talk about consecutive interior angles. Two angles on the same side of the transversal and interior. Consecutive is one after the other kind of thing. So consecutive interior. In this case, if we go back to your diagram, and I just highlight it makes it a little easier if you can identify, it's like, okay, we're talking interior here, so I can rule out the rest, right? So consecutive interior here, let me just show you the diagram. There have to be both on the inside and the same side of the transversal. So 2 and 5, as well as 3 and 8. They're consecutive. They're one after the other. They're both on the inside. So 3, 8, 2, 5. Maybe I'll just add non-adjacent, because some folks have used their, they might grab one that is right above it or beside it, even though everything already in that statement tells you what it's supposed to be. And there's vertically opposite angles. I will give you just a little diagram here, and then we're going to go grab our vertically opposite angles from the diagram we just looked at. So if you have a line like this and another one crossing it like this, these two angles here would be considered vertically opposite. So they kind of share a vertex, a point of intersection, and so these two angles would be vertically opposite. And I'm going to use a different color. These two angles here, those two would be considered vertically opposite as well. So how about we do this? I'm going to use a blue pen here. Let's call this lowercase a, b, c, and d. So angles A and angle C would be vertically opposite. As well as angle D and angle B. Like these two are also considered vertically opposite. I just call them VO. Okay. And I hope that doesn't mean anything inappropriate these days, because I can't seem to get it right anymore. I don't keep up with the times. Sometimes I come up with an acronym and students start laughing. I'm like, what are you talking about? So anyways, vertically opposite, that's what it means in this course. I will tell you a fact about vertically opposite angles. They are always congruent. What does congruent mean? This is the symbol for congruency, and that means the same, equal. Right? If you wanna, right? Congruent is the same as equal. It's the same thing. It's kind of like solving a quadratic, roots, right? X-intercepts, same thing. I told you what vertically opposite angles are here, but what about our original diagram? Could you tell me some vertically opposite angles? From diagram above, and I'll bring that diagram up again. Sorry, I might block you for a bit. Just look for now. So in this intersection here, you've got 1, 3, as well as 4 and 2. Right? They make an X like that. So these would be, so vertically opposite would be 2 and 4, 1 and 3. Then you move down, and there's another 2 vertically opposite pairs here. So there's 8, 6, 7, 5. So 1, 3, and 2, 4. Angle 6 and angle 8. Angle 7 and angle 5. Order as to which one you state first does not matter. But all of these are vertically opposite pairs. Okay. So I think it's important to do this one exercise here. Okay. So let's just make 2 lines that go like this. We're going to cut it here. And we're going to start right here at this A, B, C, D. So we started here, so A, B, C, D. We're going to start here. E, F, G, H. And I'm going to ask you to state the alternate interior angles, alternate exterior angles, corresponding angles, consecutive interior angles. Sorry, I ran out of runway there. Would you be able to, now that I twisted this on you, I didn't copy the same diagram because that's not the point, right? Would you be able to come up with all the pairs, right? Like there should be pairs in here, pairs of angles. So go ahead and try to do that right now on your own. It's okay if you go back to your notes and try to come up with all the pairs that fit in here, and here, and here, and in there. Give it a try. Okay, so let's see if we can wrap your head around this. Alternate interior. So I focus on the interior. Okay, where is the interior here? Well, you should recognize that this is right now is the transversal, and these are your buns, right? That's your sandwich. So this would be interior, exterior, exterior, right? So alternate means on opposite sides of the transversal, and they have to be interior. So B and H, as well as E and C. Okay, so that's it. That's all you have. Okay, and on the other hand, here alternate exterior, right? It's D and F, right? You're on the outside, so this will be D and F, as well as A and G. So two pair here, two pair there. Corresponding, that one is trickier, right? It has to be one on the inside and one on the outside, not touching it, same side of the transversal. So it's B and F. Then you switch over, it's G and C, or C and G, it doesn't matter. And then you can go D and H. Right? D and H here, A and E, and so forth. So you have four pairs, okay? Four pair of corresponding angles. Consecutive interior, they're right one after the other, and they're both on the inside, so B and E, as well as C and H. So there's two there. I didn't ask you for vertically opposite. I could have, but we're just going to leave it at that. Vertically opposite are easy to identify, so it'd be DB, AC, right? H, F, E, G, and they're always congruent, okay? Okay, I'm going to start a new page here. Is that starting to make sense? The naming and everything, of course, yeah, identifying it. Okay, it's a little dry, but we need to know how that works. Here, two lines are parallel if you can prove or show that one of the following is true. If you can prove that one of these that I'm gonna list is true, then you indeed can conclude that two lines are parallel. Okay. Alternate exterior angles are congruent, or alternate interior angles are congruent, or corresponding angles are congruent. Sometimes one is easier to do than the other. That's why I'm giving you options, right? Consecutive interior angles are supplementary. What is supplementary, right? They have a sum of 180 degrees. Very important to have on your. So if the question asks you, um, are these two lines parallel? Explain. You can't just say yes or no. That's a a coin toss, right? It's a coin toss. That won't fly, right? You'll have to refer to one of these to make your concluding statement, okay? And the way you show that will vary. I will show you a couple of ways of doing that, but you got to make sure you refer to these. So I would have this on my study sheet as well. Okay, this part right here. Right, if I were you, if you need to prove something, okay, that is definitely important to know. And you will forget when it comes to that, right? Our example is AB parallel to CD, question mark. Explain. So we're going to have just so you go have endpoints here, AB, C, and D. And we're gonna, like, you can't see it, can you? My bad. So AB and CD, right? And then we're just gonna randomly name this XM, just to break up the pattern, right? So AB, CD, and then XM, which is our transversal, right? And I will give you some measurements. This angle right here measures 113 degrees. And this one measures 113 degrees also. Okay, so the task is to show that they're parallel, okay? We don't know at this point. There are no markings, anything else. All we have to go by are the angle measures. So the first thing is identify pairs of angles we have a name for. If you have a name and they meet the criteria, then lines are parallel. Or else, if they're not, then they will not be considered parallel. Okay, so using a highlighter just to show you, right? you kind of first thing you look at it, you're like, okay, I've got some numbers here and they're the same, right? And so in your mind, you'll be like, okay, I'm going to highlight that. And then you're going to look at the location of them. You know that this is your transversal, and these are your two lines, which we're trying to see if they're parallel or not. What do we call these two angles? Do you have a name for these two? Yeah, they're obtuse, yeah. But as a pair, what do we call when one is here and one is over there? What do we call those? Yep, angles. Yeah, that's right. So you were just supplementing each other there. Okay, exactly. These two are called alternate exterior, right? You have a name for it. And so you have a name for it. Do they meet the criteria? Let's go up here. Alternate exterior, if they're congruent, then the lines are parallel, right? You've just shown that this is true. You don't need to show all four. I'll tell you later on that if one is true, all four are true. So you're just going to focus, okay, I've shown that, therefore I'm going to get the mark here, okay? So, um, yes, right? AB is parallel to CD, and why will you say? Because alternate, because you won't have this on the question, right? Alternate exterior angles are congruent. You can use this or you can use this. It's up to you. That's it. In this case, it's as simple as that. But you can't just say yes or no. That won't work. Okay? And so let's keep going. B. Let's make one that's a little trickier here. So I'm going to have that and two lines going this way. Lots of diagrams, okay? And we're going to do the same thing. A, B, C, D. We're going to call this XM. We're going to have 150 here. We're going to have 43 here. And that's it. Just copy that part down. The question is still, is AB parallel to CD? Do we have a name for these two angles here? Do we have a name? They're both exterior, right? But as a pair, do we have a name for them? We don't. We don't have a name. Here, okay, find measures of other angles, until you find a pair that you have a name for, of course. Okay. So here's where you're gonna have to have like, you're gonna have to be able to zoom out, right? Zoom out and sometimes zoom in. It's up to you. Okay. So I'll tell you what the game plan is here. Okay. My game plan is this. This is a straight line here, correct? It's a straight line. What do I know about these two angles? There's a property I gave you at the very beginning. You remember when you take a straight line and you cut it, these two are always, they always add up to 180, correct? That's always true. Use that to your advantage. So this angle here, if I were to find what this is, okay, I'm going to use a red pen. If I were to find what this is, do we have a name for these two? The answer is yes. This is what we call alternate exterior, right? So my game plan is if I find what this is, now I have a pair that I have a name for, and I can make a conclusion. But I need a pair that I have a name for, one of the four that I give you up there. So I'm going to go 180 minus 150 here. And that gives me the 30-degree angle that I need here. Okay, so this is part of work, folks. If you did this, I would take that as work. Okay, because this is a straight line. Any straight line, use it to your advantage. So I'm looking at these two here. I have a name for those, right? And you would simply say, in this case, they're not congruent. So you have to conclude saying no, right? AB, this line right here and this line right there is not parallel to CD. Alternate exterior angles are not congruent. Right? You can use one of those. So somebody's saying, somebody at home or here, I can guarantee you somebody saw something else. Okay, somebody saw, well, Mr. Dirksen, isn't this a straight line here? Wouldn't you say that I could just go 180 minus 50 to get this one? And then you get 30 here, right? So maybe you don't copy this just yet. But first of all, didn't I tell you that vertically opposite angles are always equal? So you could have used that property. But what do we call these two here? This is the complicated one that I gave you that long definition for, corresponding angles. Corresponding angles also would need to be congruent, but they are not. So regardless of which route you take, you will arrive to the same conclusion if you do it right. So I will say here, also corresponding angles are not congruent either. Okay, this is another justification. You only need one. Okay, you only need one. And there are more, by the way. If you get really creative, you could have started on the bottom here, found this angle here, right, which would have been 37, right? No, what am I saying here? Not 37, 137. This would have been 137, and then you're like, hey, wait a minute, alternate exterior angles here are not congruent. So that's completely fine. And some of you will find it frustrating because you want to be able to have a cookie cutter approach that works every time, and I will disappoint you there. Okay, it's just the way this works. Okay, we've got 9 minutes. Let me see here. Yeah, I think I'm gonna stop there. So homework, we'll do a lot more tomorrow, okay? Oh no, right. Page 72, 1 to 5. It's not that much. It's a bit more concept based, but it's important that you know how to do that. Also, if you were, I think I'm a broken record, but that package when you wrote the test, those handouts, make sure you have them on you all the time. If you don't, I have some extras. It's right behind Yuvrak there. There's a stack there of paper, so if you need it, get it. But tomorrow you're gonna need some of those handouts already. Okay? Everybody at home, you can sign off. Thank you.